Yeah, so yours.
I actually really like that it's a report to the cloud.
Yeah.
So much easier.
Alright, now we should probably start the recording, right?
I started it.
Oh, okay, cool.
All right, guys, please have a seat.
Good luck.
Thank you.
That's the nice thing about these exams, they're real epic with you. They're like, if you get a 17, you can have desserts. Yeah, I got it, and then immediately got it. Nice.
There's this,
I'm
and there's
looking at for all the.
off the ground.
Yeah, but that's what I'm doing this time class. He's been fighting scams. Okay, it's an attack mode.
Sorry. We're talking about virology labs, we found the previous word.
It's okay. Okay. Okay, welcome guys to workshop 4. Today we're gonna go over top 10 OWASP, which is the top 10 web security vulnerabilities that are common across the entire internet. So what is OWASP, first of all? Okay.
Top 10 odds.
Yes. Yeah. Top 10 OWASP, and then like a nice advertisement in the middle. Before we get started, please look at this company. Yes. Okay, so OWASP is a actual foundation that was founded on the idea that we need to improve web security of software. So the whole point is to research and figure out what is the most common software vulnerabilities and to display them so people like us who are developing and figuring it out can look at these and be like, okay, that is something I shouldn't do. And they actually list stuff on their website about like common tactics that people use to attack, and also common tactics that people use to prevent those types of attacks. Their website, it also hosts a bunch of articles on just like common vulnerabilities and a lot of research documentation. So it's definitely a good site to go around and just like browse an afternoon on. All right. So what is a web's application security risk? All right. A web application security risk is anything that can cause unauthorized access to a resource on the website, or even change the website. So anything that is people from outside, even like regular people, if they can access certain portions of your site which they're not meant to access, then they can also change and cause code to malfunction if they're able to get it. Yes, Liz?
Are you gonna mention the Apache thing?
I'm actually not mentioning. I'm demonstrating. I'm going to demonstrate SQL injection.
Oh.
Yes,
Yeah.
the most common one.
The Apache thing is
No, it's
harder to find them.
It was on a website. Yes, Adam?
Oh, does OWASP only cover web applications or any
Yes.
software?
WA.
So yeah, they only cover web applications, but they do, however, have. Hello. Oh, hi.
Welcome, sorry.
No, you're good. They do, however, cover networks. It's Gabe. Gabe gets a good old cameo. So yeah, they do cover also networking, because as it attains to the web, right? So their main portion of their site is just website security, and anything that requires web security, like firewalls and stuff like that, they will also demonstrate how to prevent people from accessing it. Right. All right, time for the top 10 OWASP. So the way, oh yeah, sorry.
Are they ranked by how common they are?
Yes. It's ranked by how common they are,
Oh, okay.
right? So you'll see that the first one might not be as security vulnerable. Because hopefully you coded it right where you can double check if someone's doing something. But they're ranked by how common they are.
Okay.
Yes.
This is like poor coding practices.
The first one is. Okay, so let's actually,
How many of them are poor coding practices?
all of them are poor coding practices. Yes.
How do they determine commonality? Is it like based on past breaches, or do they have a record of like all websites and what current vulnerabilities there are?
So they base it on breaches. And they have a research team that goes over what's common, and usually what happens is a lot of like web developers like Apache and stuff like that that create servers will release patches showing what they fixed. And the most likely thing that they fixed is something that people usually do wrong. But you'll see that the first one especially is it's just a coding problem, not a actual like someone found a vulnerability in the app. Yes.
How do you smack the developers to not do this shit?
Have them actually read and look up the vulnerabilities, so they actually understand what's going on. Then I'm sorry, but fire them.
Typically, people cut corners are just not skilled enough. Which is like.
They
So how
think
many
of
of
the
them?
both.
They didn't think about it. So look, I will in the first one. I will demonstrate like how common it is and how like what can go wrong. So actually let's get into the first one. All right, let's get into the first one. So broken access control. I sorry, Zoom. Yes. So broken access control, a user that can go outside their permissions, right? So a request from an authorized user to another endpoint that is not supposed to be accessible by that user, right? So if I go out here, let's see, and we are gonna start up the broken access control server. It's listening on port 800. So I'm gonna go to port 800. Localhost port 8000. It should not be 80.
Unmap yourself.
It's
They'll find it.
Oh, it's 8080. It's actually 8080. Okay, so this is a simple website that I made. As you can see, it shows absolutely nothing. And
Is this where they can change like the user and the URL, like user admin special? If you can type it in and hit enter, you can end up on that page.
kind of, yes.
They
Yes.
did that in CCDC.
Yes.
I
So
did not know how to fix it.
I will show you how to fix it. So there's two ways of fixing it. Depends on the actual code. So a function is not being called properly, or you don't have endpoint security on the configs. So saying that you need to be a certain type of user to access this endpoint. So okay. Let's log in as Mike. Mike is a user. Mike is Mike Lee. Actually, I should have done this the other way. Okay, my bad. We're gonna log out. See, we logged out. All right, we're gonna log back in as Jeb. All right, Jeb is an admin. I just want to show everyone the admin privileges, right? Okay, so if we go down here, yeah, we're gonna look at source code and we're gonna see what we can do, right? We have login, log out, okay, and then admin. Okay, so we're gonna go to the dash. Cannot get /dash. I think it's admin /dash. Yes. Okay, so this is the dashboard, right? Very simple dashboard. If I go to users, it gives me all the users. You go to files, it gives me all the files. and there's a logout button. Very simple, very obvious stuff that like admins should be able to access, right? But there's a vulnerability on this website. If I log out and I log in as a user, so we're gonna log in as Bob. Bob is a user, right? Bob is for some reason able to access the dashboard. Not just that, he's able to get the users. And you could see that there's a bunch of users on the site. But when he tries to click files, he's unauthorized, right? So this is an example of broken access control where half of the site works, but another half of the site doesn't work, where it wasn't supposed to work at all, right? So the code here actually shows, if I go to the admin user, right, the admin control, you'll see here that the dashboard is up here. The users is up here. But the thing to actually authenticate admins is down here. So in Express, the way that functions work is that they're ordered cascadically. The function that's already on top that gets used, this is the first function that's going to execute before everyone else. So the dash endpoint gets priority in this router, while over here the files endpoint gets executed after this the use function, right? So in this scenario, you're supposed to put all of these endpoints below that authentication function, and this will fix the problem, right? So if I redo this, you'll see that I'm now unauthorized, right? And if I go,
Sorry.
you're good. And if I go to dash, I'm unauthorized, right? So this is an example. You're good. Okay, so this is an example of someone didn't put the functions in properly, and the admin function that checks if someone's admin is lower on the priority than some of the endpoints, right? And this is very common to do, especially if you have big websites where you have multiple routes, right? Sometimes you have a route that gets called, but you put it below the route, below the actual route that needs to be executed before the next route executes, right? So this is an example of broken admin control, broken access control. So let's get back into this. So,
Sorry.
yes.
I've even seen like, sometimes one of my side interests, right, is film music, and sometimes composers will post, like, usually they do it as a demo reel, so they can get hired by future companies. They'll post excerpts of music that you can't buy. And on a couple websites that I know of, you can go on, like, where you find an MP3 file or whatever, you can actually go backwards and see the entire directory of the folder and everything, download other files and stuff. I only know of 2 out of maybe 30 sites that have that, but
A lot of older websites will have that because they didn't set this up, because you're supposed to set this up on Apache configs. You tell it you cannot go back a file. Yeah, prevention, ensuring that unauthorized control cannot be made by a user who doesn't have it. So usually creating test users that will go and try to sniff the site to make sure that you can't get into certain endpoints, right? All right. Number 2, cryptographic failures. This is a very common one, especially it was more common in the past when people were switching from HTTP to HTTPS, because the reason for that switch was so we didn't have to send cryptographic keys that were unencrypted. And this shows if someone was able to sniff out, and I'll show you in a minute, the actual packet on an HTTP, you're able to see the entire encryption key, right? While on an HTTPS, the packet is encrypted, you're not able to see it, right? All right, let's get into this demo. We're gonna CD into cryptographic failures. Node server. That is not it. Server.js. All right, so I created a website in both HTTP and HTTPS to show what I mean by this. So first we're gonna access the site. If the Zoom thing will go away. Zoom?
I think you just move it down, right?
Yeah, you can.
Okay, there we
So
go.
you can use control tab. It'll cycle through your tabs or control 1.
You have to do command automatically.
Oh, wait, no,
With command.
Lots of sticky keys.
Sticky keys. Okay, so I created this simple website which will just display a key. So what will originally happen is, like, for instance, cookies and stuff like that will get transmitted from with HTTP, sorry. And people can see those cookies get passed, right? When they're getting transmitted through HTTP, people can see the entire packet, and I'll show you in a minute. While HTTPS, it's encrypted, so you're not able to see those cookies getting passed. So let me pull up Wireshark real quick. Wireshark is basically a network capturing service to show you all the packets that are coming in and out of your computer. All right, so let's request this again. We'll see a bunch of nasty requests and a bunch of things here, and you'll see here this is regular HTTP. And if we scroll down a bit, we'll see that the key, oh, this is a token, sorry. Let's see. HTML, here we go. Here it is. The key is right here. So we'll see the whole key in plain text, right? And this is because it's being transmitted through HTTP, right? But if we go on to this website through an encrypted line, it's going to tell me the same thing. But if we look here and we look at the actual packet, yes. If we go through the actual packet, and one of these is encrypted, but all of these are application data, and we'll see that, yeah, there's not, this is through TLS, so we're not actually able to see the data that's going through because it's being encrypted through HTTPS. Let me see if I can reload this. I have a feeling it's one of these, but we'll see that, yeah, it is encrypted data. Like, unless you get the key, you're not able to see this. Yes.
So this is really like at number 2. Is it just mostly older sites in this case? It seems like,
So yeah, a lot of cryptographic failures are also not just this,
oh, okay.
but also, for instance, not hashing properly,
Mhm.
not like basically handling stuff using older versions of hashing,
Right.
like MD5 and stuff like that. Yeah, stuff that's already able to be cracked very easily.
Do you want next MP3? No.
Is MD4 any better? All right. So yeah, preventions, use HTTPS when transmitting any crucial information. Ensure that you use trusted hashing and encrypted algorithms. So don't use MD5. And make sure you rotate through your authorization keys. So these are keys that are stored onto the servers when they send out, for instance, cookies and stuff that only they can read. Make sure you're not setting them and forgetting them. So rotating them through. Okay.
Wait, go back a second.
Yes.
You know why? Like a lot of older software or platforms used to make their own encryption keys or algorithms. Like I know a lot of things that are vulnerable today were proprietary encryption algorithms like Zip 2.0 or that thing used on DVDs for like the PS3 encryption algorithm where they implemented it wrong and then
Well, that wasn't proprietary, that was,
Oh.
they just implemented it wrong.
but it was still a custom implementation though. They didn't use libraries. Like, you know why that was
No,
so
They did use the library, I'm pretty sure, it was just like they reused the same key for everything, that's what.
Yeah. So yeah, to answer your question, the reason is that one, we didn't really standardize what we wanted to use until like a few years ago. Not a few years ago, but like 10 to 15 years ago. Yeah. When we were children.
But wasn't that also more work though?
To what?
To make something new instead.
Well, we didn't have the ones that we had,
Right.
right? So if we look back, I forget when SHA 256 came out.
It's like
Uh,
mid 2000s.
Yeah, mid 2000s.
Uh,
Right. So we didn't have the ones that we needed.
2001.
2000. Yeah, there you go.
I remember seeing like some old internet forum discussions from like 2005 or 2006 about like switching from MD5 to SHA-2, because like this was right when MD5 was broken. There
Yeah.
are, like still people who were complaining about like, well, is it really that big of a deal if I just use MD5? Does it really matter that much?
So preferably use the strongest algorithm you know. Unless you for some reason need speed, use the strongest one you know.
Really kind of similar, but CCDC database had an encryption setting on it. It gave you two options, MD5 or SHA.
SHA.
So I picked SHA, I changed it, I hit save, and it refused to work.
Was it already hashed?
No. It killed it, so I was like, okay, I'll change it back to MD5. So I did, and then that didn't work again either.
That sounds like it was already hashed. If it's already hashed, then you'd have to save the database as a backup, hash it again, and remake. Yeah.
Well, you also can't just hash it again because you can't go back.
Yeah,
to
you
the
can't
hash
go
of the
back.
original thing.
Yeah.
So like, if it's already hashed, you sort of just like can't do
How
much
do you
about it.
defend an MD5 that's already?
Make sure the passwords don't get.
MD5 isn't like that severely broken. It's probably not worth like. It's probably not worth changing if it's gonna be like a massive headache. MD5 is mainly broken for like finding collisions, but you can't like crack an MD5 password basically.
How big of an issue is it that you're able to find? Like, are you able to find a lot of collisions and what's going on?
So like you can generate two strings that collide with each other, but
Yeah.
like if you don't know someone's password and you have the MD5 hash, you can't like reverse it. The main issue with it for password encryption though is like MD5 is really, really fast to compute, which means you can brute force it really well.
Oh, okay.
Yeah.
So like most hashing algorithms that you're actually supposed to use for passwords are intentionally like much slower. Like for example, there's some that'll like run SHA-256 like 1,000 times, just to, like intentionally make it slower. So like when you're logging into your computer, you're not gonna notice the difference between like a microsecond and 100 milliseconds. But like for an attacker, that makes a massive difference because it's the difference between like an hour and a few months.
Yeah, exactly. Okay, so next one, injections. Injections are any type of user input or stuff that can be inputted from into a request, which is meant to change how the request is handled. This is usually by accidentally treating user input as code. A prime example is SQL injections, which return the entire database if you format it correctly. It can also modify, add, and delete stuff from the database. So Unironically, yes, you could do that. So if I go here,
1 = 1.
CD into let's see, injections. OWASP. So I have here a simple SQLite database. I'm trying to.
It's all equal without any of the words.
This is valid.
SQLite is not.
You also don't have to expose a port to use SQLite, unlike every other SQL database.
Well, yeah, because this is like internal. Like it uses a file.
And reducing
That's
the
great.
attack surface.
Okay, so this is listening on port 300 because I decided to use a different port every time.
Why do you use a different word every time?
It's whatever.
It's just all hosted in
It's not fun. Okay, so
Also, you can run multiple of them at the same time.
Yeah, because this is a secure, like 5 hour, very secure website that you built. Very simple. Not the one on the dash P dash scan.
yeah, so okay, so to get into the demonstration, this is a user endpoint that's supposed to get a user, right? So there's no user called that. I actually don't know if there's actually a user in here. But we'll figure out if there's a user in here, right? So this endpoint, I've generated a input that, if given, should give us back the thing if it's coded improperly, right? If it's coded improperly, you should be able to input this thing, which does a union, and selects all from the SQLite master, and with a little star, you can select every table, and because this is coded properly, it doesn't give back, right? If I go back here and I look at what it's actually doing, you'll see that this endpoint, it does select ID, username, password, user where username is equal to this. And you'll see that the program actually escapes this and adds quotes. Actually, let me make this bigger. I don't know why I'm doing it so small. The program actually escapes this, making it so it will not detonate. And it will actually act as if this is a user. And if it doesn't find that user. But I've also coded it in an improper way, where it will actually input the raw file, the raw query into the SQL database, and we'll see that this is the entire database, just displayed, right? The reason it does this is because it unions the entire database with itself, with whatever query you have before. And that's how most people will get into SQL, by unioning a table that they do want with a table that it's supposed to get, right? And you'll see here that this actually does escape, right? Where it selects user from where user equals this empty string, and then it unions it with an all select star from the SQL master. And that will select the entire table, all the tables and everything in them, from the SQL database. And the reason this happens, if I just X out of all this jargon.
Do you know any recent SQL injection attacks that have been successful?
I don't know any recent ones, but it's a very common occurrence because a lot of SQL websites haven't been updated to the recent versions of SQL that don't allow you to just do a raw query. So you'll see here that the users get request uses a object to actually query. And this is how you're supposed to do it. MongoDB does it this way. MySQL, if you update it, and SQLite and a bunch of other ones, this is how you're supposed to do it when you're doing code, and never inputting it raw into the thing. This will automatically do the parsing and escaping So that way this username is always gonna be this string, right? It's never gonna try to escape it. And it makes it a lot easier for SQL to normalize that input. While the old way to do it was just querying the entire database and selecting where star is equal from users and inputting that raw input into it. Usually what will happen is people in the past, what they would do is just sanitize it themselves, which turns out is not really a good idea. So just use the sanitation that comes with the thing. And hopefully that the people who are working on the database are working correctly. Never trust raw input. Yeah. So any questions about this one?
So one thing I wanted to mention is that, if you're looking at this from like the other perspective of you wanna like enumerate everything from a website that's vulnerable to this, there's a cool tool called SQL Map, where basically like you just give it URL and it does all of this automatically. And it'll literally like dump the whole database.
Oh, so it like does it automatically by like doing SQL injections?
Yeah, it like does a bunch of probing to figure out like what the injection vulnerability is and how to use it to leak data out.
Okay.
And then it figures out, and then once it figures out like how to use the vulnerability, it uses it to help literally everything.
Yeah. Okay. No, that makes sense because it like SQL will not care what type of query you're sending because like there's instances where querying the entire database makes sense.
Yeah.
Right. But most of the time querying the entire database is not a good idea.
Yeah.
What were you gonna say?
So do JavaScript and like PHP injections also fall into this category?
Yes.
Okay.
Yeah. Because JavaScript injections are where you inject code into the database, and then when you run it again, it will actually detonate that code. We'll get into it later, but a user should not be able to modify your HTML or templates that you're using from any input that you're getting from the thing. You should be the one generating it. And if anyone's gonna attack a user, they should theoretically be only attacking themselves, right? So that would fall under cross-site scripting.
Okay.
Right. All right, so let's go into this next one. Okay, so prevention. Make sure you don't use raw input directly. Make sure you sanitize it, normalize it, and make sure that whatever is getting inserted into your database is the thing that you're trying to insert. Do not trust anything coming from the user, because even though most users are not going to be malicious, you only need one user that's being malicious to break your entire site. Avoid porting user input directly into the code, right? So this stems on parsing it, making sure that it doesn't detonate in some way. But this also means make sure that user input does not get personified and changes the functionality of the code somehow, right? Because there's other ways of doing SQL injections where you can get, for instance, the key of the server that's running, right? And then you could do bypasses that way. All right, number 4, insecure design. So some of these will stem on business practices. Insecure design is getting into it where a software is designed in such a way where it can't be patched, right? This is like software that's meant to be one and done. IoT devices fall into this, where if something fails, there's not really a way to patch them, right? It stems over from a lack of like business security profiling. So being able to actually figure out, okay, where are security risks in the business and in the models? And because of that, it leads to lazy ideas and risky ideas being implemented in the software. Like using regular components from just like public domains. It also means that if something fails, no one will know about it until it fails astronomically and someone gets talking to, right? So one of the ways is parse through vetted libraries. Inject integrate like possibility checks, so like create a testing suite to make sure that your application gets past that testing suite. Creating unit tests, so like as components get added, make sure that there's a way to test each part of the program, that way when they get added together you know what's going wrong. And limit user access to systems. Yes.
It's funny, if you go to the previous slide again, the yeah, that should be resolved in the planning phase part, and risky ideas. Like Adobe Flash Player, if you go back and read the original design documents from the 90s, like the original point of Flash Player was essentially to, I forget exactly how they worded it, but it was basically like they wanted to take the freedom that you could have writing a software for a local machine and put it on the web. So they were like, what if we could run local software remotely on someone else's computer? That was like the original concept.
Oh.
Yeah. And then, so then with that in mind is how they designed their player and stuff. And then they realized, oh fuck, we have to be secure. And that entire idea is inherently insecure. And so that's part of the problem.
Yeah, because it's like literally remote access execution on another machine, which is inherently the most vulnerable thing. Like for instance, it is the most vulnerable thing about browsers today is that technically you can sandbox the browser as much as you want, but if someone downloads something and then presses execute, that's how they get in, right? So insecure design is a very big thing, and making sure that, you know, don't think through the idea that you're making and how it can be exploited, right?
But what you just said also with the downloading and running, like I remember 10 years ago before I used ad blockers, going on like MediaFire to download Minecraft mods and the 25 fake buttons.
Yeah, those were fun.
Because you didn't want to pay $30.
Well, there was also, you can also download mods through it, so it was very common for people to download mods and other players.
They turned the viruses.
Right, because
Sometimes,
they download buttons.
Yeah, the fake, yeah. You have to wait like fucking, you
So
have to wait like, yeah, like 20 seconds. Yeah, we love ad blockers. Always use ad blockers. Okay, let me see. Is there any other ones I want to do? Okay, security malfunctions. Okay, so security malfunctions. Inappropriate handling of inappropriate or missing hardening across the stack. Bad configs, so like setting setting Apache to let you do specifically, I remember CGI bin, where you're able to get into and do remote execution through the Apache website. You can actually turn that config off. And it's usually on off by default, using default passwords and allowing error handling traces to be revealed to the end user. So I have an example of this. If we go back to here, where you could cd into security malfunctions, node server. All right. If we go back to this endpoint will automatically throw an error. Sorry. I think it's homepage. So this endpoint will automatically throw an error saying no homepage exists, except the end user gets all this information about the server, right? So you get where it's stored, So now everyone knows my name and the repo endpoint. So good luck trying to get into my computer though. But you get like a bunch of stuff about what's installed on the server and also how is the server running, right? So you'll see here that also this is an Express server, right? So Express.js. So you can probably look up some vulnerabilities in Express.js and see if you can get in through those, right? So leaving error traces left to the end user is a big no-no. But it's also very common because if we see here, we go back to the code, the way that this is done is just use error handle. And then the error handle function is just this, where it just renders the error, right? To correct this, making sure that the production version of the code is the default, that when you run the code, it is in production. And then you have to set it to the dev mode, right? So you have to set it to the debug mode, making sure that like the ones that when you run the software, you actually have to set a variable to make sure that you're in the dev mode, right? But by default, this is a very common thing, especially when you're debugging. People will render out track traces to make sure that their website works. All right, so let's get back into this. So prevention for this, right? Implementing workflows that are easily deployable. For instance, using Docker containers. So you only have to update a Docker container if you need to change anything. Locking down and removing unnecessary features. So removing components that are not needed on the software side. Removing unnecessary console logs is also very important. And deploying an automatic processing feature across config files. So maybe have a certain config file that you guys use because you guys have vetted it for Apache, a certain config file for whatever you're using for like Express or PHP or like whatever you're trying to use. Make sure that you have a default config file that is secure, right? All right. That leads us right into number 6, which is vulnerable and outdated components. So a lot of these components and libraries that you get off of online, some of them are outdated. So when you pip install something from a repository, it might be outdated or not managed. So there might be security risks using repos that you have not vetted, right? Also using public components is very insecure because anyone can upload to those components, right? Another big example is also using IoT devices that are connected to your network, because they're also not awfully vetted, and they can easily get access to certain parts of your network through the IoT device, if they're close enough in proximity. Yes.
That's, I believe, for the PS3 for sure, and maybe for the PS4 also, like the main, I mean, there's a couple ways to hack the PS3, but one of the main ways that works today is some vulnerability in WebKit.
Yeah.
That's in the PS3 web browser if you don't update it, and I believe the PS4 has the same thing, although the PS4, there are updates available for it,
Yeah.
but so most PS4s now are updated, but if you have one that isn't patched yet,
You can do probably like kernel exploits, basically.
Yeah.
Okay. Yeah. See that makes sense because the way that the reason WebKit is even available is so you can access the web on the PS3, but those also it needs functionality from the kernel to be able to actually display everything.
Yeah.
So yeah, that would be a way for people to get in. So before we get into prevention, there's actually a article here about yes, someone uploading fake VMware to PyPy the PyPy package. Basically, the PyPy package is a common repo that people use for VMs, and VM connects. And they were able to upload fake remote execution code to the package repo. And luckily they caught it in time, but as you can see, there was over 200 downloads to download a VM Connect before PyPy took it down, right? We don't know exactly what it was for, according to this article, but it looks to have been a command and control to the servers, to the attacker servers, right? So making sure you vet components before you use them, removing unnecessary components, so minimizing the amount of things that can go wrong, continuously logging what you have deployed, so knowing what versions you have deployed out, obtaining components from a trusted repo, so creating a trusted repo in your company to make sure that creating a trusted repo in your company to make sure that people who want to use the repo are using it, you are using the trusted version of the software that you want to use. Also monitoring if you have to use old libraries, monitor for security patches. And also maybe try to invest in securing those libraries yourself, or creating the same versions of those libraries which you've already vetted, right?
One thing I'll say before I put out also the example that you said, my internship in the summer, one of my coworkers had downloaded some software that was genuinely useful for security researchers. I forget exactly what tool it was, but apparently it was a fake tool that was made by some like North Korean ABT, and it was like, a genuinely useful research tool, and it was open source too, but it had like this straight up remote code execution and Brad built into it, and
Oh no.
nobody bothered to leave the source code, and so like thousands of people had this thing installed on their computers for months, including my coworker, and he ended up just throwing out his personal computer and replacing it.
Oh my, yeah. So yeah, making sure that you vet the software you're using.
Again?
Yeah, he was like trouble for that, like 5 years. I feel like that's like a pretty big problem.
He wasn't using it on his work computer, it's just his personal.
Oh.
Yeah. It's also a lot of these things, like, yeah, it can be said that like, yeah, you should have known better, but sometimes you just don't know better, right? Like if you're downloading off of pip install, you're like, oh, this is probably actual software, right?
How many people in this room who've used open source software have read the source code of software they use? Of course not.
Yeah.
For every single applicant.
No, exactly. So, but okay, so getting into the habit of actually looking at the source code that you're using, right? Or having someone on the team looking through the source code, right?
The PyPy, what does that like to do?
Package index. It's where it's packages from.
Yeah, it's yeah.
Oh, so like ultimately like PyPy.
Yeah.
Yeah.
Like pandas and.
Yeah.
Yes. So they uploaded a module called VM Connect, which was supposed to connect to a VM instance, but it was actually a command and control software.
Wow.
Right. Okay. Number 7, identification and authorization failures. So permitting automatic password attacks. So this is not stopping password attacks from going, not stopping password attacks from being automated. And
Dude, can we go over this?
What?
The guy who-
No.
I can go ask.
There's like a
So-
whole group of people playing it outside.
So, yes.
I
So making sure that password checks, and every time you like fail a password, that it doesn't just allow you to do it forever, right? Some examples of an identification or authentication failure is using a weak password like password one. Knowledge-based security questions like what was your mother's maiden name, that can easily be searched up on Google, especially if you have a Facebook, right? Where did you go to school? Like, where was your elementary school? So stuff like that can easily be searched up and be able to recover your password by actually just changing it, right? Storing passwords in plain encrypted or hashed or weakly hashed algorithms, right? This was very common until it became commonplace for people to hash passwords. It was common for people just to encrypt the password and store the key to encrypt it on the software anyway. Because before hashing algorithms, that's how passwords were stored. But once we transferred to a hashing algorithm, it made it a lot harder for passwords to be decrypted. Reusing the same session for repeated successful logins. So this is more attained to the cookies that are sent between sessions. This is less common nowadays because it's very easy to regenerate a different key for a session, or a different cookie for each session. But some websites used to keep the same cookie as your authentication cookie for your entire time you've successfully logged in, and they always return the same thing, right? Nowadays with, for instance, JWT, that automatically gets salted, so you don't ever return the same thing for even the same data that you're sending. Preventions, yeah, using a strong password. It's very simple, but yes, yet many people fail it. There was I forget what it was, but someone recently got caught.
I don't know. I'm left-handed. Yeah, it doesn't. Yeah, I don't know.
But yes, sorry. I forget what it was, but there was a big company recently that was hacked because their secretaries had weak passwords. And they were given admin privileges, right? Never store passwords in plain text, and don't give your secretaries admin privileges. Or you don't use reversible encryption. Also don't use encryption on your passwords entirely. Use hashing algorithms. If you want, you can encrypt the hash, but don't keep regular passwords on your device. Last thing, have timeouts between password fails. Usually what people like to set it to is 3 password fails, and they time you out for 5 minutes. That will severely make it a lot harder for people to get into the computer. Yes.
Would like keeping like ex-employee credentials like still the same fall in this category?
Yes.
Okay,
Yes.
that's a big one.
So yeah, definitely keeping ex-employee credentials is definitely a security risk, because they shouldn't be logging in. Theoretically, what you would do is you deactivate the account, and if someone tries to log in, you would use it as a honeypot of some sort.
You disable it before they get fired. You actually are supposed to disable it like the morning that they're supposed to be
Yeah.
fired. And as an ex-Rutgers employee, I can tell you, Rutgers has a huge problem with this. They haven't disabled a bunch of credentials.
I don't know about Rutgers, but
Oh, Rutgers
Yeah.
doesn't, that's what I'm saying.
Cyrus still has swipe access to the cave, right?
yes.
Super
Yeah.
bad. They're really bad at it.
I still have a swipe access to my internship I worked at.
Oh,
That's
that's not great.
That's not good.
All right, guys. Yes, so number 8, and I do have to wrap up this quickly because I do have to go in a few minutes. Number 8, software and data integrity failures. So code that relies on other services that might be vulnerable. So even though they're a trusted source internally, if they also don't have a security analyst and like all the security shabazz, they can be a security risk for you because they have access to APIs and certain things that on your own servers. The attackers can also take advantage of auto updates and upload their own updates without verification. So for instance, the components side, if you have auto updates done on pip, for instance, and a package was sent, or an update was sent into the pip repos, and it had malicious code, the code would be auto updated into whatever you're doing, and one, you wouldn't know, and two, even if the repo decides to revert it, it might not revert on your end. So making sure that you don't use auto updates for specific things that are untrusted, right? Prevention, using data hashes for whatever data is coming in. So making sure that you actually verify with whoever's sending the data over, that they're sending the right data and it hasn't been tampered with. And then vetting and using trusted repos to make sure that libraries have also not been tampered with. Number 9, security logging and monitoring failures. So this relies more on the company perspective. So these are softwares that don't have good monitoring infrastructure, don't have good monitoring over the network even, and you're not able to detect any data breach, right? So let's say that, for instance, that there was a secretary's we're using secretary a lot. Let's just say an office worker's computer was not being monitored, right? Let's say they brought in their own laptop, right? And their own laptop had a Trojan on it. So when they went to log into their website, to the work website, they're able to capture the cookie that you logged in with, right? And if there's not a good way of monitoring who connected and from where, you won't know that that is the vulnerable computer, and that is what allowed access into the rest of the company through that person who was already infected, right? Another one is unclear messaging logs. So this is done very simply because the way developers work is sometimes very fast. So their mission is to log debugging instead of actually log securities, right? So you'll get a bunch of debug logs, but not actually what actually happened. Yes?
Wouldn't a lot of these problems be solved by installing the system event information, system information event manager?
So yeah, so you would be able to, so for instance, having a centralized way of looking at Windows events. Yeah, it would help. But this is more on the network side. So on the business perspective, it's kind of very hard to see all of the computers that are logging in and using your network, right? Because people like to use their work laptops, their regular laptops, like those become interchangeable. Yeah, so one of the ways of preventing this is maintaining a good audit log of what's going on in your network, making sure that you scan all traffic, and have a database store on all traffic. Do not store logs in the cloud. This is very common because of Amazon, but if someone's able to get into those Amazon logs, they can just clear them. So anyone who's on the network is able to just clear those logs very easily, if it's on the cloud, right? Use scanning tools such as like Nmap or internal port scanners and stuff like that, that will scan anything on any computer that connects, disconnects, and see what your network is doing at all times, and then create alerts for possible breaches. So create a system of looking at logs and parsing through logs, which will alert you automatically if you see a foreign address accessing a foreign IP address that is not whitelisted, right, for some reason. Okay, so number 10, this one's a little weird. Server-side request forging. So this is where requesting to a server, where the server itself gets its request tampered with. So a requester can think that they're trying to request a resource, but it's not actually the resource they're trying to request, right? It's very hard to explain in the sense that it has a lot to do with what's getting stored where, and the difference of getting those, the difference between looking up something and actually using that thing, right? Well, a lot of times these are vulnerable to what's called time to use attacks, which are basically the time it takes between looking up if something exists on the server and actually using that thing. What you can do is making while something is checked if something exists, you can make it look like something else in between those checks. It's very hard to do. That's why this is number 10, but it has been more common through people removing resources just by providing a URL, right? It's basically trying to mimic what the server would request to another server to get a resource, so to a database. So this is usually used in conjunction with SQL injections or cross-site scripting. But you're trying to attack a server through a server that's already vulnerable, and forging those requests. So yes, one prevention is network level by adding a deny by default policy. So only allowing certain things from going through and logging all traffic. The other way is application level, where you sanitize all user input and add a schema to your URL input. So making sure that whatever the user puts, if it's outside that schema, it just gets denied right away, right? Okay. Thank you guys for coming.
No honorable mention?
Honorable mentions, every time Microsoft has been hacked.
What's project gets a phone call?
That would be under injection.
Injections,
Oh,
yes. Okay,
Oh, yeah, yeah, okay.
so I'm sorry, I can't take any questions because I have to leave.
Oh, big man.
We have any
What?
questions? We can just discuss the questions among ourselves.
Yes, I can join the Discord server if you really want, but thank you guys for coming. This will be recorded and sent into the URL. Can you just sign out for all this?
Did you on the meeting?
Not yet. Please stop.
Labor split.